wanted to include this video just as kind of a little bit more practice with that whole idea of cis and trans, which I referred to in the video as E and Z, which is a little bit more appropriate. But here are just a couple of examples of different compounds that exhibit cis and trans isomerism, right? And so there's our trans, where you can see like the bulkier group is on the opposite side of the double bond. And then the cis, where the bulkier groups are on the same side of the double bond. Of course, in the video, we learned that this one is called Z. This is same side. And then this guy would be called E. There is another type of isomerism. That was geometric isomerism, which is something that's present in double bonds. And we'll actually find out it's present in cyclohexanes and stuff like that, too, to a certain extent. But that's the constitutional isomerism. So I wanted to talk just a little bit about that type of isomerism. Here are some constitutional isomers. The idea of constitutional isomers are that you have the same exact elements, the same numbers of carbons, the same numbers of hydrogens, the same numbers of oxygens, of nitrogens, et cetera, but they're just connected together differently. And so here's just probably the most easy to understand example of constitutional isomerism. And here, by the way, you'll notice that there's a few of these, common nomenclature things going on. First of all, that little N that you will often see in organic, that's an old-timey way of representing what's called normal chains. So normal pentane, for instance, the normal means that it's just a straight chain of carbons, right? No branching. You also have this prefix called iso, which always reminds me of a Y, right? So here's the Y. So that's an example of, in this case, isopentane. Of course, in the IUPAC, that would be 2-methylbutane. But, you can kind of see that, it's pretty important to kind of understand a little bit of common nomenclature as well. This neopentane is another common nomenclature that we would actually call a 2,2-dimethyl propane. So keep in mind, constitutional isomers have the same chemical formula, but all the atoms are connected together in a different order. Here's another example of that constitutional isomerism. You can see here that that same kind of deal is, oops, sorry about that. There's N-butane, right? It's a straight chain. And then isobutane is something that has that little Y in there. So that's kind of helpful to know. I also wanted to let you know that within the PowerPoint that I'm going from right now that's available on the Week 2 module of the Canvas, there also is a list of all the different official IUPAC rules. If you have any trouble with naming, I'd recommend you go here. This slide's also fairly helpful in kind of highlighting different things that we'll occasionally see. We, of course, talked about methyl and ethyl group. And then you've got the N-propyl group. Keep in mind, that's a common nomenclature thing. Normally, it's just a propyl group. We've got isopropyl groups, which have the Y in there. And then there's these 4 different types of groups, which really are not IUPAC accepted. But it's still a good idea to know that these exist. So you've got N-butyl, which has 4 carbons, and isobutyl, which has 4 carbons where one of them's in a Y. This sec-butyl is probably a little bit less common, but it's kind of got a lengthened Y over here. So in other words, all of these groups are kind of hanging off of a longer parent chain, right? So imagine each one of these kind of ends at a longer parent chain. This one is incredibly important, this thing called a tert-butyl group, which is a way to put a whole bunch of sterics in a molecule. But more on that later. Just wanted to give you kind of a quick tip sheet on some different things from this PowerPoint that you should pay attention to.